During the following presentation, we'll discuss the relationship between gesture and language in individuals with autism spectrum disorder. As Alat suggests, language is built upon a primitive gestural system. In the same way, Bates and Dick state that language and gesture are intimately related and are indeed a close family. Between 2001 and 2004, Gentilucci and collaborators showed that language and gesture share the same communication mechanism. With this in mind, we'll proceed to explain how the brain is developed in children with ASD, the way their language system is affected, the impediment of fluid social interactions on individuals with this spectrum. Finally, we will also explore the pedagogical implications in teaching children with ASD.
To begin with, according to a website called Autism Speaks, autism or Autism Spectrum Disorder, ASD, refers to a broad range of conditions characterized by challenges with social skills, repetitive behaviors, speech, and nonverbal communication. So there is no one autism but many subtypes, and each person with autism can have unique strengths and challenges. Just to clarify, autism and Asperger's syndrome are subgroups of the autistic spectrum. The key difference between them is that in autism, the child will learn to talk at a very late stage, often saying no words before the age of 2. The child may also have learning difficulties with a below average IQ and developmental delay. In contrast, in Asperger's syndrome, children will talk on time and have no learning difficulties, although they will still find socializing very challenging and often be obsessed with narrow topics of interests. Children with autism have trouble communicating. They have trouble understanding what other people think and feel. This makes it very hard for them to express themselves either with words or through gestures, facial expressions, and touch. Behavioral symptoms at the first year of life are not specific to ASD, and the symptoms that are diagnostic of ASD gradually unfold in the second year of life. The lack of early behavioral markers is a critical unmet challenge because early detection allows for early intervention, which is effective in decreasing impairments and results in more positive long-term outcomes for the child.
There is no known single cause for autism spectrum disorder, but it is generally accepted that it is caused by abnormalities in brain structure or function. Brain scans show differences in the shape and structure of the brain in children with autism compared to neurotypical children. Researchers do not know the exact cause of autism, but are investigating a number of theories, including the links among heredity, genetics, and medical problems. Because autism and Asperger's syndrome affect boys far more often than girls, Cambridge neuroscientists have been driving research into fetal testosterone in order to examine its effects on brain development and postnatal behavior. Cambridge has analyzed the effects of prenatal testosterone levels produced by the fetus and measured via amniocentesis during the first trimester of pregnancy on autistic behavior. Fetal testosterone shapes brain development to alter an individual's cognitive profile by binding to androgen receptors in the brain, the amygdala being one region that is rich in such receptors. Strikingly, Cambridge researchers have shown that higher prenatal testosterone levels are associated with reduced social skills, but superior attention to detail in infants.
The parts of the brain that are mostly affected by ASD are the cerebral cortex. The 30 billion neurons of this part of the brain carry out movement, sensation, planning for the future, and social behavior. Altered structure and connectivity may lead to changes in these activities in individuals with autism. Detailed microscopic studies suggest that there may be an increased number of connections between some of the neurons in this brain region.
The amygdala is the danger detector of the brain and may be responsible for anxiety that is common in autism. This brain part is often too large in young people with autism, but is smaller in autistic adults.
The hippocampus makes memories. It is bigger in many people with autism. This change may be associated with the intensive behavioral therapy that many people with autism experience in early life.
The temporal lobe. It is important for language, hearing, and seeing. One part of the temporal lobe, called the fusiform gyrus, allows people to detect differences in the faces of individuals. Many studies indicate that this part of the brain has altered neurons and connections.
The glia. Besides neurons, the other cells in the brain called glia. These provide support to neurons and also contribute to immune function. Evidence suggests that some types of glial cells are too active in autism.
The cerebellum has 100 million neurons that control detailed movement of the body. About half of the people with autism have a smaller number of a specific type of cell called Purkinje cells.
Now we would like to refer to the relationship between language and gestures. Many authors who are experts on the subject state that the first speech-gesture link that appears to develop is the onset of canonical babbling together with the onset of rhythmic hand-banging. Canonical babbling is defined by Euler et al. To be well-formed syllables containing a vowel-like and a consonant-like element, such as dada and ba. This form of babbling is an important milestone, usually achieved in typically developing children between 6 and 8 months of age. Failure to produce canonical babbling by 10 months is a strong predicator of delays in words acquisition and words combination in the second year. Many authors found that vocalizations co-occur together with rhythmic actions. In fact, these vocalizations were similar to mature speech, that led the researchers to the hypothesis that the rhythmic hand-banging may contribute to the infant's ability to perform articulatory actions that are necessary for spoken language acquisition. Therefore, canonical babbling does not appear to develop in isolation, but rather appears to be closely linked to rhythmicity of behavior, which is action.
The use of gesture has been reported to correlate with word comprehension, to predict expressive language development, and to facilitate syntactic development in language production. In typical development, the first signs of word comprehension emerge between 8 and 10 months of age, and it is around this same time that children begin to produce actions associated with objects in their environment. These early gestures are critical to child language development because they precede first words and they soon co-occur with the production of first words. For example, a child will point to a ball and say ball at the same time. Shore et al. Show that recognitionary gestures and naming emerge at the same time, that gestures and naming are positively correlated, and that these gestures are first words and similar in context. Interestingly, This correlation between gestural naming and word production is evident in typically developing children at only around 12 to 18 months. Bates and D suggest that once language develops sufficiently, the more primitive gestural symbol system is no longer necessary, and the child then relies solely on verbal communication.
One area of growing interest in the understanding of the relationship between language and gestural processing is the Autism Spectrum Disorder. Gesture is a vital part of communication which occurs without conscious thought in everyday conversation. Gesture is an ancillary system to speech, lacking the grammatical and semantic constraints of language. It is nevertheless integral to communication and forms complex temporal and semantic relationships with speech. Gesture is an unintentional action usually performed by the hand or arm in the area of the upper torso, for the most part accompanying speech and often in face-to-face interaction. Participants in interactions are adept at differentiating between intentional communicative movements and other movements such as mannerism and fidgeting. Gestural impairments in autism have been reported. Kanner published a description of a child from his original research. Her expression was blank, though not unintelligent, and there were no communicative gestures. One of the greatest sources of communication difficulty that families and caregivers face when dealing with preverbal autistic children is that they do not compensate for their language deficit through the use of functional gestures, failing to spontaneously use conventional gestures to make their needs known. In autism, children may present with a disorder of gesture, a language disorder, or a combination of both, and this gesture-language link may be disrupted at any level.
In order to assess gestural processing in a population of high-functioning individuals with high-functioning autism and Asperger's syndrome, a research study was developed. 8 appropriate objects and gestures were presented using video clips as stimuli, and objects were tested both in direct imitation and in novel use modalities. The results revealed that the individuals with autism performed the imitation task more poorly than the controls. Rogers and Pennington suggest that the individuals with autism had difficulty seeing others as templates of the self. In other words, impairment in imitation from infancy may affect bodily synchrony and mutual coordination. This asynchrony, in turn, may affect the ability of the infant to coordinate both emotionally and physically with the caregiver, resulting in a deficit in self and other awareness.
Recently, Hobson et al. Suggested that interpersonal communication and social interaction requires the awareness of self and other, and that this intricate concept is reflected in deictic terms and gestures, including the appropriate use of pronouns. The use of inappropriate pronouns based on the speaker roles may implicate the children's limited engagement in the stances of other people. In some, children with autism may experience difficulty identifying with the orientation in speaking of other persons and show atypical pronoun usage.
Despite the triad of impairments, which includes a language delay, individuals with ASD can present with an array of strengths, including rote memory, calculation skills, perfect perspective drawing, and absolute pitch. Whilst occasionally these skills may be raised to savant level in some individuals, there are exceptional perceptual abilities consistently revealed in individuals with ASD. As an example of this, we would like to show you a short clip from a movie called Raymond. This movie tells the story of two brothers who meet after their father dies. Charlie Babbitt, played by Tom Cruise, the selfish younger brother, is a wheel dealer who discovers that his strange father has left a multi-million-dollar estate to his other son, Raymond, played by Dustin Hoffman, an autistic savant of whose existence Charlie was unaware. Charlie is left with only his father's car and collection of rose bushes. Raymond has savant syndrome and adheres to strict routines. He has a superb recall, but he shows very little emotional expressions, and it happens only when he is in distress. Charlie decides to attempt to gain custody of his brother in order to get control of the money.
Are you good with numbers?
Yeah.
I read about this. I want to try something here.
Kmart, 400 Oak Street.
What'd I tell you after this, Ray? After this.
Ray, can we try something?
Yeah.
Do you know how much 312 times 123 is?
38376.
He's right.
What?
He's right.
He's right?
Yeah. Ray, how much is 4,343 times 1,234?
5359262.
He's a genius.
He's right.
He's a genius.
Ray, do you know how much the square root of 2,130 is?
46.15192304. 2304.
That's amazing. I mean, that is amazing. He should work for NASA or something like that.
If you had $1 and you spent 50 cents, how much money would you have left?
About 70.
70 cents?
70 cents.
So much for the NASA idea.
Kmart. You should go to Kmart.
What'd I tell you after this, Ray?
Ray,
After this.
400 Oak Street.
Ray, do you know how much a candy bar costs?
About $100.
$100, huh?
Yeah.
You know how much one of those new compact cars costs?
About $100.
In his particular case, he's pretty well off. He's very high functioning. Most autistics, they can't speak or they can't communicate. Ray,
Yeah.
do you know what autistic is?
Yeah.
You know that word?
Yeah.
Are you autistic?
I don't think so. No. Definitely not.
To conclude, as future teachers, we consider that it is important to take into account these syndromes when teaching, as it is a reality that we may encounter within the classroom. That being said, we reflect upon its importance and thus propose the following teaching strategies.
As autistic individuals experience language difficulties, lack of social interaction skills, unusual or challenging behavior, learning difficulties, unusual pattern of attention, unusual responses to sensory stimuli, and anxiety, make it very difficult for autistic students to be happy in a social environment such as a classroom. The numerous social interactions can cause autistic students stress because of their inability to interact with the students appropriately. Since autistic students have difficulty keeping relationships, they may feel isolated or rejected.
Learning disabilities negatively affect autistic children, such as trouble paying attention to relevant cues and information, inability to plan, organize and solve problems, deficits in concept formation and abstract reasoning, and impairment in social cognition, which includes deficits in the capacity to share attention and emotion with others and to understand the feelings of others. These learning disabilities may cause the autistic students to fall behind other students in the class, which may make the autistic children feel inadequate to their classmates and even frustrating with their inability to perform basic school tasks.
Autistic students' responses to sensory stimulation such as touch, the texture of objects, sounds, doors, and visual stimulation can range from hypersensitivity to hypersensitivity. Therefore, various everyday school stimuli may be disturbing or even painful to autistic students. Autistic individuals need to be aware of the sensory stimuli that negatively influence their behavior and, whenever possible, avoid these stimuli.
A teacher encounters many challenges when teaching autistic students. To help autistic students to be more successful in the classroom, teachers need to modify instruction, provide students with strategies that help them to function in the classroom, and develop an individualized program plan with the assistance of the parents, administration, and sometimes the child.
Language difficulties. Teachers must focus instruction on paying attention, imitating, comprehension of common words and instructions, using language for social reasons rather than using language to have basic needs met, functional communication.
Social interaction difficulties. Teachers need to make sure that they provide opportunities for meaningful contact with peers and teach them to tolerate others in the same physical space, imitate the actions and vocalization of others, engage in parallel activities with others, share materials, take turns when participating in a familiar activity, and use eye contact to initiate and maintain interactions.
Unusual challenging behavior. Teachers need to teach them strategies to expand students' interests, develop skills across a variety of useful areas, monitor the level of arousal or anxiety, prepare for planned changes, calm down and reduce anxiety. Although teaching autistic students strategies to reduce their unusual or challenging behavior does reduce this behavior from arising, teachers need to be aware of how to deal with the challenging behavior if a situation is to arise.
Learning problems. Teachers need to incorporate visual material into their teaching. Autistic individuals are visually oriented. Use visual supports for communicating toys. Teach key social rules like waiting, taking turns, making transitions, changing the topic, finishing, initiating, being flexible, being quiet.
Unusual patterns of attention. To help autistic students with their unusual patterns of attention, teachers need to be clear and concise, be consistent with students' comprehension levels, focus their attention, and emphasize the most relevant information.
Unusual responses to sensory stimuli. Teachers need to try to create a classroom that will not provide students with situations that are overstimulating. Be aware of the different experiences of sensory stimulation and know how to respond.
Anxiety. Teachers need to provide warnings about upcoming transitions and changes. Daily and weekly schedules to increase predictability. Calming strategies or coping skills. Factual information regarding fear or anxiety arising in situations, such as what to do when I'm lost. A common area within the classroom.